Hey, this is Mr. Ward, and I'm going to do a video key for Geometry Exit Ticket 20.2. So here we go. Which of the following choices would be best suited to prove Theorem 34? So Theorem 34 says, if two lines are cut by a transversal such that a pair of exterior angles on the same side of the transversal are supplementary, then the lines are parallel. So as with the previous ones, really what you're looking for is something that says this in reverse, because we've been given that 1 and 7, these are exterior angles because they're outside the set of parallel lines, and they are on the same side of the transversal, and we've been told they're supplementary. So what we want to do is take this idea that they are supplementary, we're going to look for one that goes in the reverse of that theorem. So that theorem says, if they're cut by the transversal so that they're sup, that those two angles on the exterior angles on the same side are sup, then the lines are parallel. So we find one where the exterior angles, so here, theorem 28, if two parallel lines are cut by a transversal, each pair of exterior angles on the same side of the transversal are supplementary. So this is just saying the same thing in reverse. So here it's if two parallel lines are cut, then you get this result. And here you've got if they're cut and you get that result, then they are parallel. So this is the one you want. Just doing it in reverse. Okay, and you might be seeing a pattern here. Which of the following choices would best be suited to prove Theorem 35? If in a plane, if two lines are perpendicular to a third line, then they are parallel. Okay, so let's look for something where in a plane, if a line is perpendicular to one or two parallel lines, then it is perpendicular to the other. Now, this one, I probably need to change this into a more open response type of situation. And I'm going to change the question a little bit from what is in this version for this video. So when you get this, it's going to actually talk about if you were to draw a transversal through these, how could we use that? And you could use any of a variety of strategies. How could you use that to prove this theorem? Theorem 36 says, if two lines are each parallel to a third line, they are parallel to each other. So there's a variety of ways that you can prove that. So if we drew a transversal there, then you could, if you could demonstrate, since they are parallel, we could say this, right? We could say that this is congruent to this, alternate interior angles, and then we could, actually, let me back off on that one. You could then also treat this and this as alternate interior angles for B and A, okay? And you could also treat this as alternate interior angles for B and C. So we know A and B are parallel. A is parallel to B, and B is parallel to C. So A is parallel to B, and B is parallel to C. So if we could use the fact that A and B are parallel, let me actually erase some stuff and start over here. If we drew a transversal through here, and we know A and B are parallel, then we can say that this angle is congruent to this angle because they're alternate interior angles for a transversal cutting through two parallel lines. Then we say B and C are parallel, so we know that also. So then we could say that this angle here is congruent to this angle. So then you've got now we've got this angle is congruent to this, but this angle is congruent to this, and now you've got a transitive property thing that then says that these two corresponding angles are congruent. And then we could prove that A and C are parallel because we have Theorem 26, each pair of corresponding angles are congruent. However, there are other ways you could have approached it. So we could have instead used something else. So since we've drawn a transversal, we have other stuff. So we could, in fact, start with, for A and B, this angle and this angle are corresponding. And so they're going to be congruent. And then we could just say, since B and C are parallel, then we could say these two corresponding angles. And then once we have that, then we have bitransitive, they're all congruent to each other. And then A and C, once again, can lead us to corresponding. But you could have gone a different path. There are a variety of ways you could do this, and I'm very curious what you come up with. I will now stop, and I hope this has been helpful.